Section 1.4, Part 2 video. Want to continue factoring trinomials. The problem that I wrote up right at the end last time of the last video, I put up this trinomial right here, and we looked at it and we said there's no GCF. But then we also said this is not the what we refer to as the easy trinomials, because that number right there is something other than 1. So if that number in front is 2 or bigger and there's no GCF, this is what we call the harder case. So when you factor this, you can't just say, well, I need 2 factors of 2 to subtract to give me 3. That won't work anymore. Because see, this 5, it could be a x and a 5x, or a 5x and an x, with the 1 and the 2, or the 2 and the 1, so it completely changes the dynamics of this problem. Now, depending on who you have for a teacher, depends upon what technique you use. And there's 3 or 4 different techniques by using different names when they teach students how to factor this. The one that I use is probably the quickest for most students to pick up on when I'm reviewing in this fashion. Now, I didn't say that it's always the best. There's arguments for every one of the techniques. So I'm just going to show you the method that I teach in intermediate because it's the one that most students can kind of pick up on. And it's a little bit of a gimmick, if you will, and I'm not all about that a lot of times in mathematics, but it is one that's easiest for me to teach and get through. So let me show you that. Anytime I factor a trinomial, that's what I call the harder case, I use what's called the Brew method, B-R-U. A lot of teachers don't call it the Brew method, they call it the bottoms up method, is what they call it. But I put that R in between the bottoms up part. You'll see what that stands for in just a minute. You'll see why I put that letter in there. So anytime you hear me use the word Brew method or bottoms up method, same thing if you were taught that, it's basically factoring a trinomial, the harder case. All right, so here's the little trick on how you do it. What you do is, to get these 2 binomials, you come to the side and you start out with this 5, and you multiply it by the number that's on the end. So leave the x squared minus 3x alone, and multiply 5 times the number on the end, which is 10. Let me make sure you can see that first. Okay, yes you can. Alright, so take the number on front, multiply it times the number on the end. So you get x squared minus 3x minus 10. When you do, you get a new problem. But notice that this is an easy case now. So let's factor it. X squared breaks up x times x. Signs are different. Largest is negative. So my biggest number is going to go right here. Alright. Now, how do we do the easy case? 2 numbers that multiply to give you 10, that subtract to give you 3. Multiply 10, subtract 3. 5 and 2. 5 times 2 is 10. You subtract 5 and 2, you get 3. But the 5 needs to be with the negative. So x plus 5, x minus 2. I'll say this multiple times. This is not the answer to the factorization of this. This is the factorization of this problem, not this one over here. So that is not the answer to my problem. This is where the 3 letters B-R-U comes from. The letter B. The letter B stands for bottom. And so what you do is, under the bottom of this 2 and under the bottom of that 5, divide by the number that you started out multiplying by. If you'll remember this 5, what did we do with that 5 with that 2? We multiplied it. So we did 5 times the number on the end. Now we're going to undo that. Instead of saying 5 times the numbers on the end, we're going to do 5 divided by the number. So under the bottom of that number and that number, under the bottom, put the number you started out multiplying by. Now the letter R. R stands for reduce. Does 2 over 5 reduce? It does not. Does 5 over 5 reduce? It does, to 1. Now the last letter stands for U, for up. What that means is this. If you still have a fraction after you reduce, bring this number that's in the bottom, bring it up in front of the x, so you don't have a fraction. So that would be 5x plus 2. And there's no number to bring up over here. I mean, there is, but it's an understood 1. So if you bring that up, it's still going to stay x minus 1. And so this trinomial factors as 5x plus 2 times x minus 1. Now, is there any way that I could check this? Certainly. If you FOIL this out, it will take you right back to where you started. All right, let's do one more here. Let's do this one. 20x squared minus 34x plus 12. Now, when you look at this problem, if the first thing you say is, okay, this is not the easy case, you're getting a little ahead of yourself. First thing we do is look for a GCF. Does this have a GCF? Is there something that will go into 20, 34, and 12? Certainly. 2 will. And 2 is the biggest thing that divides into those. Now, there's not an x in every term, so your GCF is not 2x, it's just 2. When I do, this would be 10x squared minus 17x plus 6. All right, we said this a while ago. I will say it again here. Remember, when we factor, the goal is not to factor. It is to completely factor. So what I want to do here is I want to try to completely factor this problem. You say, well, will this factor again? I have no clue. But I won't know until I check it. So what I'm about to try to do is try to factor this. If it doesn't factor again, then this will be my answer. But if it does factor again, I will have to factor it. And if it does factor again, that 2 will be part of the answer as well. Now, how do I determine if this factors again or not? I have to check it. Well, it's a trinomial. Is it the easy case or is it the harder case? Well, if you look at this, you will recognize that this is the harder case because of the 10. So what I'm going to do is I've got to come to the side and do that brew method that I just mentioned a while ago. All right, so go to the side. I'm going to give you just a second, let you work ahead of me. Go to the side and try the brew method and see if you can come up with the factors there that work. I'll give you just a minute to do that. Now remember, when you do the brew method, you have to take the number on the front and the number on the back and do what with them? You have to multiply them together. So don't forget to do that when you do that brew method. And I could have just told you to pause the video and let you work ahead of me as well. So I keep forgetting about that. All right, so let's see what you did here. All right, so we're going to take the number on the front, which is 10, and the number on the back side, which is the 6. So we're going to have x squared minus 17x plus 10 times the number on the end, 6, which is 60. Now keep in mind, when I do the 10 times the 6, which is 60, when I factor this, this is not the answer to this problem. All right, so this is a trinomial, the easy case now. So let's see, x squared breaks up x and x. Signs are the same, both negative. Now I need two numbers. When you multiply, you get 60. So let's see, you got 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. So there's more combinations of 60 than you'd think. All right, we need two numbers that multiply 60, add 17. Now, if this were a minus, I would be subtracting 17. In that case, I'd use the 3 and 20. But we're not subtracting to get 17. We're adding to get 17. Which of these two numbers adds together to give you 17? 5 and 12. So I will put the 5 here and the 12 here. Now, that's not the answer. Now the brew method comes in. B. B stands for bottom. Under the bottom of these two, put the number you multiplied by in the beginning, which was the 10 times 6. Now you divide by 10. Don't forget to reduce. If you do not reduce before you bring up, your answer will be wrong. 5 over 10 reduces to 1/2. 12 over 10, 2 goes into both of those, reduces to 6/5. Now bring this number up, so this becomes 2x minus 1, 5x minus 6. And so that completes the factoring review that I wanted to go over with you. Now, you don't have any homework, any problems in the homework where you're strictly just factoring. But you're going to need to know how to factor in order to work the problems that we're going to be looking at in section 1.4. Okay, so we're really just now about to begin section 1.4. And so section 1.4, over here. I'm going to look at what's called quadratic equations. Now, for those of you, if you happen to have had intermediate before, we covered some of this in the intermediate class here at Jones. If you've had intermediate, and if you've had Algebra 1, Algebra 2, you certainly have covered this, but may not have covered all of this section, but you certainly covered part of it. So let's start out, and I'll give you a note. Let me make one other comment before I give you the note. Remember, in this course, starting in section 1.1, we solved our first type of equation called a linear equation. Now remember, a linear equation was an equation of the form AX equal B. Now, did all of the problems look like AX equal B? No. I mean, some of them were really long. But if you played with them long enough and got the x's on one side, numbers on the other, you ended up with AX equal B. So let's start out and take several notes down. So take this first note down. Here's the note. A quadratic equation is an equation that can be written in the form, and then write this form right here down. And remember, you can pause your videos. AX squared plus BX plus C equals 0. Now, let me explain to you basically what this means. Equation means the presence of the equal sign. Quadratic. All right, so look right here. Notice that you have an x squared here, and notice that a cannot be 0. So that means that you have to have the x squared present in every quadratic equation. So there's two distinguishing features about every quadratic equation. Number one, you'll have an equal sign. And number two, your variable will be raised to the second power now, not to just to the first power. Remember, in a linear equation, you had x's maybe listed multiple times, but they were all to the first power. So the distinguishing feature about every quadratic equation is you will have an x squared in the problem. If you don't have an x squared in the problem, it's just a linear equation. So you have to have the x squared. Now, you don't have to have the x squared and the x. Notice it didn't say that b couldn't be 0. So you don't have to have this term. You don't even have to have that term. But you have to have the equal sign and you have to have the x squared for it to be called a quadratic equation. Now, when we teach intermediate, we cover two ways to solve quadratic equations. And that's where we end off in intermediate algebra. All right, take this next note down. Here's the next note. Let me say one other thing, I'm sorry. We call this right here the standard form for a quadratic equation. The standard form. So in other words, when you put it in this order, that's called standard form. All right, now take this note down. I'm sorry about that. Here's the next note. There are 4 methods that can be used when solving quadratic equations. There's 4 methods. And if you want to pause the video now and write down these 4 methods, let me make sure you can see all that. There are the 4 methods. So pause the video and write those down. Okay, so we've got the factoring method, the square root property, completing the square, and the quadratic formula. So there are 4 methods that we're going to use to solving these equations right here. Remember, the goal to any equation is to solve it. But you don't solve quadratic equations the way you do linear equations. It's 2 completely different games. The rules are the rules are entirely different. So here are the methods that we use. Now, why do we have multiple methods? Well, let me get a little ahead of myself. You're going to find out that not all of these methods work all the time. Sometimes one of the methods will work when the other one won't. And so that's the reason there's multiple methods. Now, linear equations, we only use one method. I gave you the 4 steps. I gave you your recipe to solving linear equations. Well, there's 4 methods here. So what we're going to have to do, and it's very important that you take good notes, every method has its own steps. So you're going to have to make sure that you take good notes, and you're going to have to make sure that you memorize or learn, whatever you want to call it, the process for each of these 4 methods. Because when it comes time for test, I will tell you, solve this method this way, etc. And I'll talk more in depth about that as we go through these 4 methods. So in the next video, we are going to learn how to solve quadratic equations. We will start with the factoring method. And then we'll go to the square root property, completing the square, and the quadratic formula. So this concludes our factoring review and our preliminary notes on section 1.4, part 2 video. So we will begin with part 3 video, actually solving quadratic equations by these individual methods. And I'll have to give you the processes in those videos.